All right, so then in 6, where we have the a coordinate, but we don't have a y coordinate, so let's find our y coordinate first. All right, so y is going to be 6e. Well, my value of a is e, so I'm going to get an e to the e minus natural log of e. So natural log of e we can simplify. That's going to be just 1. So I'm going to get 6e raised to the e minus 1. That's our y coordinate. All right, so the next thing we need is to find the derivative, dy dx. This will give the slope of the tangent line. 6e to the x has a derivative of 6e to the x. Natural log has a derivative of 1 over x. So if I evaluate this thing when x is equal to e, I'm going to end up with 6e to the e minus 1 over e as the slope. I'm going to clean it up a little bit just because I want to be able to reciprocate this thing. So let's see, we need least common denominator, so I'd have to throw an e down here and multiply this by e. All right, so it's going to get a little fun. This is like e to the first power, times 6e. So look, this is e to the first times e to the e. They have the same basis, so I can just add the exponents. So this is going to be 6e to the e plus 1 minus 1 all over e. All right, so that's going to be the slope of our tangent line. So if I want to get the normal line slope, the normal line's slope, I'm just going to take the negative reciprocal, right? So the reciprocal is going to be e over 6e to the e plus 1 minus 1, and then negative just to make it a reciprocal, perpendicular. So then finally, we could say that our normal line is equal to our value of y, which we got to be 6e to the e minus 1, plus our slope, which is just this thing that we just found, minus e over 6e to the e plus 1 minus 1 times x minus our value of a, which was minus e. I'm sure we could clean this up a ton if we just distributed and move some things around, but you don't feel like doing that. I don't feel like doing that. We're in agreement. So let's just put a little box around this thing and call it a day. Call it a night. It's dark behind me.